watch this too, Brady. So I'm gonna show you how to create a unit circle, blank unit circle from scratch. You can do this in less than 2 seconds, 2 minutes. I'm gonna do it while explaining it to you. The first thing you do is you draw in your 30-degree angle, so 30 degrees, and you draw it all the way through. So that and that are going to be the same. Those are going to be the same. Do the same thing with the other 30-degree right there, 30, 30. Those are going to be the same, right? All 4 of those are going to be the same. Okay. In fact, they're going to be positive, positive. They're going to be negative, positive. They're going to be negative, negative, and positive, negative. So you can just put in the negatives. It's going to be, that one's going to be negative. They're both going to be negative. And this one's going to be negative. Okay. And you know it's going to be, think about what the circle is. That is a 30, that's a 30-degree angle. So this is going to be the half, right? So the y coordinate is going to be half, right? Because see how that's a 66, that's a equilateral triangle right there. So this distance is half of the hypotenuse, and the hypotenuse is always 1. It's a unit circle. That's why it's called unit circle. So this is all going to be a half over here. And if those are a half, then you know the other one is, of course, root 3 over 2, right? Root 3 over 2, root 3 over 2, and root 3 over 2. So you're going to do the same thing now with the 60-degree. So this is just going to be the same thing, but it's going to be flipped, right? So draw it straight through. See, I'm just drawing it straight through. Just draw it straight through. So you know those are just flipped. It's 1/2 root 3 over 2. It's negative 1/2 root 3 over 2. Look at your positive, positive, negative, negative. This is negative 1/2 negative root 3 over 2. And this is root 3 over 2. Sorry. 1/2 comma negative root 3 over 2. Got it? And then do the same thing with the 45s. Go straight through. This is just a diagonal line straight through. It's your y equals x line, right? Go right straight through. Oops, that was bad. Right, try to make it straight through. And those are, of course, going to be your root 2 over 2, root 2 over 2, negative root 2 over 2, root 2 over 2, negative, negative. And yeah, you can just do the first quadrant, but why not just do all of them? Just get it over with, right? It doesn't really take you that much longer to do all of it. You might as well do it so you could kind of turn your brain off for finding all the values, right? So let's put the points on here as well. So this point is going to be 1, 0, the x and y axis. This point is going to be 0, 1. This point is going to be negative 1, 0. And this point down here is 0, negative 1. So now what I do is take I'm going to create a little space for my degrees and radians. And I like to put them all kind of in the same rough area. So erase that little part if you want, or if they were nice, your teacher would have given you already a pre-made one that has spots for it, right? But if not, just do that and just take your values and plug them in. Now watch how you do radians. It's actually easier than degrees. The radians, this is, oh, sorry, I didn't do this one yet. Hold on, I gotta get, this one here is gonna be pi, right? So this is pi radians. And if that's pi, then the blue are 1/6 of a pi because there's 6 30s, right? There's 6 30s and 180. So let's count by 1/6. There's 1/6. There's 2 6, but as I'm writing it, I'm reducing it. There's, dang it, I forgot this. This is 3 6. I'm sorry, 3 6 is 1/2, right? So I'm reducing it as I'm writing. This is 4 6. I'm reducing it as I'm writing it. This is 5 6. See, I'm skipping the green because those aren't 30, right? Those aren't a multiple of 30. That's 6 6. This is 7 6. This is 8 6. Reduce as you write it. This is 9 6 right here. 3 pi over 2. This is 10 6. Whoops. Reduce it as you write it. 10 6 is 5/3. This is 11 6. And that was, of course, 12, 6, or 0. Okay. And then now do the green ones. The green ones are just 1/4. That's 1/4. We already did 2/4, which is 1/2, right? This is 3/4. This is 4/4. The pi is 4/4. This is 5/4. 6/4 is the -1, the negative y-axis, and 7/4 is right there. That makes sense. So radians are actually, honestly, easier than degrees, in my opinion, because you're counting only up to 12 at the most, as opposed to degrees, you're counting 30, 60, 90, 45, 91, 225. Like, it's a little, to me, it's actually harder to do degrees than it is radians. I don't think I have to do the degrees for you though, do I? But there's your unit circle. And then all you're doing is referring back to this when you need it. Oh, one other thing I like to write in here, I'll do it in red for this one, is the tangent. I like to write like off to the side. So the tangent is going to be the y divided by the x, sine divided by cosine. So in your head, that divided by that is 1/√3. And don't even simplify that. You know it's √3/3, but just leave it like that, because usually you'll see it like that, right? This is just 1, and then that has to be √3. And these would be negative, right? -√3, -1, -1/√3. And these would be positive, 1/√3, 1/√3. And these would also be negative, -√3, -1, -1/√3. You get why?
Yeah.
Because this is positive divided by a negative, or negative by positive. This is right. And these are the same, which means those are going to be positive. Okay, but these, remember what we were talking about, these angles are all the same. Those ones, so these all have to be the same. Same with the yellows, those are all the same. And they're actually the flip, or the reciprocal of the blue ones. And then the green ones are kind of the oddball ones, those are the 45-degree. But the yellow and the blue are really the same triangle. Those are the same triangle, they're just flipped on end. In fact, that helps you understand why they're called cosine and sine. Co means it's a co-function. The cosine of 60 is the same as the sine of its complement, and the complement of 60 is 30. The cosine of 60 is the same as the sine of 30. That's why they're called cosine. Co means complement or complementary. They're co-functions, or I like to say complementary functions. These are the same. They're the complement. Same with tangent. So the tangent of 30 is the same as the cotangent of the complement, which is that. So this would be 1/√3. So the 1/√3 is the cotangent of that. Does that make sense? And that's another thing to keep in mind when you're doing this. All right, makes sense.
Yes.